Math 7, Chapter 4, Section 4, Finding and Approximating Square Roots. Perfect squares. Perfect squares are numbers that are formed by squaring some smaller number. So an example would be 2 times 2. 2 times 2 gives us the product of 4. So 4 is the perfect square number created by squaring 2. Another way to look at 4 is 2 rows of 2. We see a perfect square 4. We could take the next number up from 2, and that number is 3, and we could square it. 3 rows of 3 give us the next perfect square number, which is 9. Good. So 3 squared is 9. 9 is a perfect square number. So a perfect square number has an integer factor that can be squared to equal its value. So let's take a look at perfect square numbers and the number that was squared to create them. So we can take the first 8 counting numbers, 1 through 8, and if we square each one of these, we will create perfect square numbers. 1 squared is 1. 2 squared is 4. Good, that's a perfect square number. 3 squared is 9. 4 squared is
16.
5 squared is, and so on, all the way to 64. So these are the first 8 perfect square numbers. So the square root is the number, the base number, that is squared to create the perfect square numbers. So if m is squared to equal n, then m is the square root of n. In an example with real numbers, 6 squared equals 36. Then 6 is the square root of 36. Good. So let's try finding the square root of the actual number 36. Well, this symbol you see outside of the 36 is a radical sign. Okay, a radical sign tells us to find the square root of the radicand, the expression inside of the radical sign. There are actually 2 possible numbers that are, when squared, equal 36. The first is 6. Good. This is the positive root, right? The positive root, or also called the principal root. So principals are positive. The next number that could be squared to make 36 is negative 6. Negative 6 times negative 6 is also 36. And so this is not the positive root, this is the negative root. Find the 2 square roots of each number. So we might want to pause the video and come back to see the answer. Okay, the 2 square roots of 100 are 10 or negative 10, which may be written as plus or minus 10. The 2 square roots of 25 are plus or minus 5. The 2 square roots of 169 are plus or minus 13. And the 2 square roots of 121 are plus or minus 11. Very good. When asked for the 2 square roots, you give both. But when evaluating radical expressions, we look in front of the radical to determine which root is being asked for. These are the 3 options. When you see no sign in front of the radical, we are looking for the principal root, positive square root. If there's a negative in front of the radical, that means find the negative square root. And we might see both positive and negative in front of the radical. Plus or minus means find both the positive and the negative roots. Okay, let's try this. Example A and B. Which root is being asked for here? Good, the positive root. So the positive root of 49 is 7. How about this one? You can see we're looking for the negative root. So our answer is negative 12. Very good. Here are a couple of other questions for you. How about this one here? The answer is, good, negative 6. Now, this is an interesting question. We have a fraction in the radical. This means that both the numerator and the denominator are we're being asked to find their square roots. So we can rewrite this fraction as the square root of 9 over the square root of 16. Because they're both perfect squares, we can find their roots. The square root of 9 is 3, and the square root of 16 is 4. So the square root of 9/16 is 3/4. Very good. Another tricky question is finding the root of a decimal. The nice thing about this decimal is 25 itself is a perfect square. So what is the square root of 25? Good, 5. So now if we want our base, our square root, if we want the radicand, what's here, has 2 decimal places, so the root will have 1 decimal place, right? So the square root of 25 is 5, so the square root of 25 hundredths is 0.5. 0.5, 5/10 times 5/10 will give us 2 decimal places, 25 hundredths. Notice that we were being asked for the negative root, so we have the negative 5/10 given. Okay, and one other tricky little fraction. In this case, the numerator and denominator are not perfect squares. So another option, rather than breaking them into a numerator over a denominator as we did in problem C, we might just go ahead and perform this operation. This operation we see in a fraction is division. So what is 162 divided by 2? It is 81. Good. And so now we have the square root of a perfect square number, 81. And so the principal square root of 81 is 9. Excellent. Our final question today is, how about approximating a square root of a non-perfect square, like 70? How can we just give an approximate value for the square root of 70? Well, to do this, we are going to estimate what 2 perfect square numbers 70 falls between, okay? And 70 falls between the perfect square 64 and 81, right? And the square root of 64, we know, is 8, and the square root of 81 is 9. So, is the square root of 70 closer to 8, or is it closer to 9? Let's see, 64 is just 6 numbers away from 70, and 70 is 11 away from 81. So which of these 2 perfect squares is 70 closer to? 8. So our answer will be 8. Okay? We just round to the number, the integer that this root is closer to, which is 8. Let's try this again. How about the square root of 41? What 2 perfect square numbers does 41 fall between? Well, 41 falls between the square root of 36 and the square root of 49, doesn't it? So, which is it closer to? 36 is just 5 away from 41, and 41 is 8 away from 49. So, the square root of 41 is closer to the square root of 36, and the square root of 36 is 6. Good. So we would say the square root of 41 is pretty close to 6. How about 249? This is a larger number, and the square root of 249 is something between 15 squared, 225, and 16 squared, which is 256. So what would we say that the square root of 249 is closer to? Well, let's see. 249 is only 7 away from 256. But 225, 235, 45. So this is actually 24 away from 225. So 249 is much closer to the square root of 256, and the square root of 256 is 16. Okay, in the classroom we have a chart of common squares all the way through 20 in the front left side underneath Queen Fiona. So you can look there for the common, or the first 20 perfect square numbers, which would help you with this type of question. So today you're going to do a short review on page 179 and then answer these questions on page 216. And I hope you have time to complete this in class. If not, maybe a little bit of time outside of class, and you should be able to do this with no problem. Have fun!